Okay, so this is the second lesson on transformations. And so what you're going to find is that today we are going to be doing the opposite of what we did yesterday. Or, well, not yesterday, last class. Last class, you guys were given a parent function and then given another equation, and then you had to describe what the changes would be. And you could look at the equation and tell what has happened. Sometimes you could just graph it either in Desmos or on a graphing calculator, and you can see what happened. But today is a little bit more tricky because you really have to know what affects what. So you're going to see, here's that same guide that we had before, the A, B, C, and D and what it does. And the same thing works with square roots, though we're not going to do square roots, so I'm not going to pay attention to those. But you'll see here, like understanding what happens here. This is what we did last class. So this right here, this right here is a change in the C, which is the horizontal shift. So that being -1 means that this would go right 1. It's a quadratic, it's an x squared, so it's a parabola that's just been shifted to the right 1. And this is all we did last class. This one here, the negative sign out front, would invert it, so this would flip graph. So a parabola would then just be upside down. And that's sort of what we did last class. But what's going to be different now about this class is we're going to go backwards. Now we're going to tell you what the transformation is, and you have to write the equation. So this is a little bit more tricky because it's not so easy. You can't just plug it in and just see what happens. So you can use a graphing calculator to figure out what if you put your answer in to see if what happened was what was supposed to happen. So you have to really understand what a translation of 2 units to the left actually means. What does a movement left or right? What letter does that affect? Remember that you have A on the outside. This is B, the 1/3 is B. You have a C that would be on the outside, but there is no C. And then you have a D that's on the outside. The C is on the inside. So what letter is that? Well, then you have to know translation 2 units left. Okay, well then left and right. Here's left and right. It's a horizontal shift, so I know that affects the C, so I know that is that. You also have to know that it's the opposite of, remember, because on the inside, B and C act opposite of where you think it would be. So left doesn't mean negative like you might think it would. So 2 units to the left is actually not -2, but +2. So we can rewrite this function to be 1/3 x, since 2 units left here affects the C. That's the only one I'm affecting. And it's not going to be -2, but it'll be +2. And so what you can do to check your answer is put both of those in to your graphing calculator or Desmos and see if the transformed one, which is this one, is a translation of this one, just 2 units to the left. And you'll see that it is in fact true. So for these type of functions, and it's going to give you that transformation, and you have to adjust the equation appropriately. With number 2, it's a translation 6 units down. So you have to understand that down is a vertical shift. And vertical shift is D. It's going to affect this one on the outside. So it is going to affect, here you have A, here is B, though there's nothing there. You have a C, and here's D. So it's going to affect this piece right here. Everything else stays the same. A negative absolute value, x plus 9 absolute value. So now in order to shift it down 6, we would have to do -6. Now it's already -1. So when we have -1 and then we translate it down 6 more units, it becomes -7. And so this would be my new function. okay? So it's supposed to be g of x, whatever, but that would be the answer. And you could check it. You could put the f of x into the Desmos or a graphing calculator and then put in the other one into the graphing calculator and see if it is in fact been shifted down 6 units, and you'll see that it has. So you can do this with all of these here. So here's another one where you have your A, you have your B, you don't have a C, but that's where it would go, and then you have a D. So when it says a horizontal shrink by a factor of 1/4, that tells you that you're affecting B, because B is horizontal stretch or shrink. Now remember that this works backwards. Horizontal shrinks should be the same as vertical stretches, so they make them steeper and taller. So you're not going to just take, I want a different marker here. You're not going to take 1/4 and just multiply 1/4 times 8, because 1/4 times 8 actually will make it smaller, okay? And so it'll make it flatter. So you have to remember that anything horizontal does the opposite of what you think it would do. So you would think that you would multiply by 1/4, and that's because it's a factor of 1/4, but it's actually backwards. You can divide the B by 1/4, or just think of it, the opposite of division is multiplication. So you could, the opposite of multiplying by 1/4, would be to multiply by 4. So horizontal shrink by a factor of 1/4 because, and I just didn't mean to erase that, because this is 1/4, and because it's a factor of, you're going to think I should multiply 1/4, but actually you're going to divide by 1/4. So you're going to take, to change this B, you're going to take the 8 and you're going to divide it by 1/4, which is the same as multiplying it by 4. So that is going to be 8 times 4 is 32. So your transformed function will now be 32x absolute value minus 4. And that'll be a horizontal shrink. So again, horizontal shrink stretches opposite. Same thing with horizontal, moving it horizontally like left or right. It does the opposite of what you think it would. You would think that you would, by a factor of 1/4, you would multiply by 1/4, when in fact you actually divide by 1/4. So there's some, it says which of the transformations in 1.2 will not change the y-intercept? Well, you're not going to have to answer any questions like that, but basically anytime you move an absolute value up or down, obviously it's going to change the y-intercept. But what doesn't change the y-intercept is like when you flip it. But shifting it left or right or up or down, so any translation, so moving it up, down, left or right, will change the y-intercept. So the one that's not going to change your y-intercept is by flipping it. Let me just show you this real quick. When you have an absolute value like that, if I were to flip, let me change colors here, not the same color. If I were to flip this across the y-axis, you would get the same thing just over here. So your y-intercepts actually wouldn't change when you flip it horizontally. So you're not going to have any questions like that. I just was answering that. So reflections. Remember that reflections across the y-axis, so that's horizontal reflections. Horizontal reflections, so you have A, B, there's not anything there. There's a C, you don't really have a D. Horizontal, because that's what reflections across the y-axis, if you remember up here, reflections across the y-axis is B. To do a reflection across the y-axis, you just simply put a negative in there, and that reflects it across the y-axis. So 4 plus that negative x plus 1. Oops. And then that'll be that. Okay. Vertical stretch by a factor of 4. So vertical stretch affects this number right here by a factor of 4. So you have to multiply that number by 4. So this will then just be 4 absolute value x plus 3 plus 2. Okay, so that's all you do. So you have to understand, so when it says this, you have to know what letter is it affecting and then just affect those letters. So vertical stretch affects A, so we change A by a factor of 4, so we multiply by 4. Now if there was a number out there, like a 2 or something like that, you'd have to multiply. And so, trying to think here, says there's a graph of absolute value of x. Write a function whose graph represents a reflection in the x-axis followed by a horizontal stretch by a factor of 3 and a translation of 5 units down. So we have to then take this, okay, and let's do this one at a time. So we're going to reflect across the x-axis. So this new function, g of x, a reflection across the x-axis is a vertical reflection. So you can look up above, but it is affecting A. So what that does is it puts a negative out front. And so this is what our equation would look like right now. Then we're going to do followed by a horizontal stretch by a factor of 3. Horizontal stretch is affects B, or the number that's right there. But remember, you don't multiply by 3. You divide by 3. So you could put 1/3 or you could put x over 3. It doesn't matter. Horizontal stretch is the opposite by a factor of 3. So it's negative. Usually it'll see it written like this, 1/3 x, or you could put x over 3. And then translation of 5 units down, that simply is -5 tacked onto the end. And there is your function. That will be a absolute value function that is reflected across the x-axis, stretched by a factor of 3, and translated 5 units down. So that is it. Please do the practice. This is definitely the most difficult of the 2 lessons in transformations. Make sure you do some practice there, big ideas, and let me know if you have any questions. We will go over this again next class before we take our quiz. Thanks.